video will look at how to solve a system of linear equations first by graphing. We'll graph these in a minute, but first I want to show you there's three possible solutions that you can have involving linear equations. And the first one, I have a line here, and here's a second line, and I'll make that one different color. If I was to take the two lines and put them one on top of each other, you can see that these lines touch in an infinite number of points. So in this first example, you have an infinite number of solutions. When the two lines are separate and parallel to each other, then you would have no solutions because the first line and the second line will share no common points. So there'll be no solution to the system of equations. And then the last one is if I have the lines meeting at a single point here, well, this point is a single solution because they only intersect in a single point. So let's take a look at these two lines and see where they intersect. So in order to solve the system of equations here by graphing, what I want to do is graph this. I know my y-intercept is +5. And then the slope is up 2/1. And then when I connect those dots for the first graph, we get that. So now for the second one, the y-intercept is -1, so put a dot there. And this slope is down 4/1. And then when I draw these two lines, I'll draw it first and then I'll move it. So after drawing those, I noticed that this here is going to intersect at this single point over here. So this system of equations has one solution. That point is -1 + 3. And that's the only solution. Let's take a look at a couple other examples that use both parallel lines and two lines that are right on top of each other, which would also have the same slope. So here we have two lines and we want to notice immediately that they have the same slope. If the y-intercepts were the same, then these two lines would be the same, but they don't. They have different y-intercepts. So we'll go ahead and we'll graph both lines to see what our solutions are. So this line is a y-intercept of 5. The slope goes up 2/1. Now we'll graph the second line, and the slope the slope is the same, and the y-intercept this time is -1. So I want to put a dot at -1, and then it goes up 2/1, up 2/1, and then I'll draw this line. So these two lines are parallel to each other. They'll never intersect. So for this one, we would say that it has no solutions. Now we'll go ahead and we'll take a look at the third example. In this next example, it's not immediately obvious because this equation over here has not been simplified. So what I want to put it into the y equals mx plus b form in order to be able to graph it. I'm going to graph this first line. And what I have is a y-intercept of -5, and then it goes up 3/1. So with that line graphed, we can now turn our attention over to the second line. In order to solve this, I need to first get it into the y equals mx plus b form. And I noticed that y is being multiplied by 2. So if I divide each term by 2, we'll get the form that we're looking for. So this becomes y equals, and then I'm simplifying. And what I get is y equals 3x minus 5. And then you immediately notice that these two lines are exactly the same. So if I was to graph the second line, you notice that these two lines are right on top of each other. So this one is said to have an infinite number of solutions. So since our two lines here are parallel and one is on top of each other in the final form, y equals 3x minus 5 is the same for both. Any point that I pick on one line will satisfy both equations because they are the same equation. And just to illustrate, if I choose 0 comma minus 5, substituting in minus 5 for y, and then 3 times 0 and minus 5, I get minus 5 equals minus 5. Any point that I pick on the line will satisfy both equations. One last point that I should make: when you have the third case and it's an infinite number of solutions, they're going to try to hide the fact that the second equation is actually the first equation by rearranging it, making it not be in the form of y equals mx plus b. And they're also going to have some coefficient of y, which is what's used to multiply all three terms, to hide the fact that they're the same. So if I was to just divide each of these terms by 3, I get y plus 4x equals 2. I'm still not there because this 4x needs to be moved to the other side of the equal sign. And what I finally get is the same equation.
That was easy.